Hello, this is Mina and I'm gonna have explanation for assignment 1 Deep Learning course with Dr. Deepaj at George Brown College. We are using a fashionist dataset through the course, which consists of 10 class labels. And here, first of all, from cross datasets, import fashion list, and then load our data and images. And here you can see that the shape of train images and also test images is something like this. And the number of dimension is 3, which means training set of 60,000 examples, and each image is a 28 by 28 grayscale image associated with labels from 10 classes. And for the train labels, the dimension is 1, also which are inputs. Also, the number of dimension for this label is 1, and we are using 10,000 examples here. The length of train labels and is 60,000, as I mentioned, and test labels are 10,000. And here showing some train images and test images with importing matplotlib. You can see some of them. And here the train labels and test labels, our inputs is something like this. Is they are array of numbers, and then the digital content of train images with index of 5, which is this array. The 28 by 28 array consists of some numbers. And then here you can see the train image of index 5, the nice and colorful image, which is from class 2 pullover. And then here you can see that the train label of index 5 is 2, which means that this is from pullover, as I mentioned. And then the digital content of test images of index 500, a 28 by 28 array. And here plotting the test labels of index 500, which is again pullover and from class 2, which means that the test label for this index and the train label of index 5 are the same. And then Importing our models and layers and defining the sequential model and call it my network, and then reshaping the data and images from 28 by 28 to 784. Here means with reshaping just make the images just and just in one column, put them in one column, and using two methods, reshape and importing flatten, in order to reshape the 28 by 28 to 784. And here normalizing the image, and first change the type to float and then dividing by 255 for train image and also for test images. And then here adding the first hidden layer with 512 neuron, and using well activation, which is commonly used and is a nonlinear function, and but will output the input directly if it's possible, and if not, output will be 0. And here I forgot to mention that we normalize the image to speed up learning and leads to faster result. And adding another hidden layer with 128 neurons and the same activation as above, and also input shape 28 by 28 to matches our training and testing images. And also for the last layer, we are using 10 neuron and softmax activation. And as I write here, the softmax is useful because it converts the scores to a normalized probability distribution, which can be displayed to a user or used as input to other systems. Yeah, so this is the reason why we add the last layer and final layer of the neural network with activation of softmax. And then here the completion of our model using two different optimizer. Here, first of all, the Adam optimizer, and this is loss and matrix accuracy, and we are using optimizer to change attribute of our neural network, such as weights, to reduce losses and to reach out the result faster. And then here for finding our pattern, fitting the train images and train labels with 10 epochs. and the accuracy is 91%, and the loss I got here is 88%, and because these numbers are not the same and there is a gap between them, so we have overfitting here. And then the other optimizer here, I tried to using that ramsprop, and this optimizer and compilation and fitting the data and 10 epochs and 91 accuracy is 91%. And again here we have overfitting as the last number is 88%. And finally, as I wrote here, Adam optimizer is slower to change its direction and then much slower to get back to the minimum. But ramsprop, if I'm not mistaken about the pronunciation, ramsprop reaches much further before it change its direction. And here for the question 19, I want to say that fashionist is here to serve as a direct drafting replacement for the original MNIST datasets and for benchmarking machine learning algorithms. Fashionist shares the same image size and structure of training and testing splits, and the original MNIST dataset contains a lot of handwritten digits, and like MNIST, MNIST consists of training sets consisting of 60,000 examples belonging to 10 different classes. That's it. It's a bit hard to explain deep learning. Sorry if I pronounce some words wrongly. Thank you.